lacking when it comes to how students who are coming out of colleges view the vehicles. But anyway, that's beside the point. Point is that from there on I had to learn it, and while on the job. So that gave me the perspectives of where the challenges comes from. Why, even if I know something technically, I'm not able to execute it. Right? Between knowledge and execution, there's a lot of things that you need to consider. One is obviously how you approach the problem. Execution is a problem, right? So you want to create a vehicle. So how do you approach it? What all do you consider before you start to even put your pen down, that is, to start to sketch? What all do you consider? It cannot be simply that I have something in my imagination and I'll finish it and present it to the world. Right? Imagination is great. It's the basis of everything. But that imagination, when coming to the ground, coming to reality, you have to have certain considerations with which you refine your imagination, and then the creation happens. So when you do designing basics, so these are very basics of design. Anyone will tell you, and even probably that you have to see what will, say for example, you are creating a motorcycle. So what is the target? Right? No motorcycle is meant for everyone. Some motorcycles are meant for going on the tracks, some are meant for carrying luggage, some are meant for families, some are meant for youngsters. So you need to know your user profile. What is the user that I'm targeting to? And from there comes what kind of motorcycle he will be interested in. Right? What kind of vehicles he or she will be interested in. What kind of features they are looking at. All those things. Then cost effectiveness. Now cost effectiveness doesn't mean you have to go low cost. Comes from this. Someone who is looking at a sports bike, for him cost effectiveness is not necessarily a 1 lakh rupee bike. For him cost effectiveness is 5 lakh rupee bike. So cost effectiveness then again depends on user profile. What kind of product you are building. But in that, you have to consider cost. So, again, cost effectiveness not just in terms of what your final product is. Cost effectiveness is also about what material you will use, what processes you will use, because processes can be costly, or processes can be very low cost. Then, if the process is low cost, then part cost might increase. So cost effectiveness also in terms of what is the back end. Right from design, how much time you take, to what kind of tooling investment is required, what kind of automation is required, to finally what the product is. So cost effectiveness, while you look at cost effectiveness, you also look at the process. Most of the processes which are very low cost tend to have very high cost components. Like for example, when you look at FRP, fiber reinforced plastic. Fiber reinforced plastic tools are very cheap. It's 5x of the component cost. But the component cost is almost 5x compared to when you go for a injection molded part. So again, depending on what product you are doing, so if it's a product which is going into large scale production, then it will be advisable and it's better to go for high tool cost where the part cost will be lower. But if you are doing something like a Porsche or a McLaren will do, wherein they only build 100 vehicles, there you go for lower cost tooling, part cost higher doesn't matter. So cost effectiveness is, again, you have to consider full based on your user profile. Durability, this is most important. it's applicable, you have to consider durability. As in, products typically have a life of, we call it beacon life, 10 years. So we want to do a product which lasts for 10 years. Obviously not all components will last for 10 years, right? Brake shoe will wear out. But then while designing, you design, how do you make it durable? Any guesses? How do you make something durable? Okay. Most important consideration when you are doing durability is to design it for more than your requirement. Anything you do for just the requirement will fail very soon. So you do it more than the required. So 140%, typical industry standard. If you are a German, you will do 300%. But then cost effectiveness problem is there, right? So your requirement is, say, for example, in terms of tensile strength, you have requirement of 1. You do it for 1.5. When you design it, you consider 1.5 as the requirement, not 1. Your system is saying 1 is required. You do the analysis. Aesthetics, obviously. Nobody buys a product if it doesn't look good, right? Unless it's an industrial product. So you are doing a 2-wheeler, 3-wheeler, whatever, it has to look good. But what is aesthetics? Is aesthetics only about the outer shell? Will you buy a vehicle where you see under seat, you open under seat, which is not supposed to be opened by anyone, right? Supposedly it's a locked seat. And you see inside that it's a very crudely fabricated one. Or you see a component which is hidden inside, but it looks like a shabby product. Right? It's doing its job. So aesthetics does not mean that you only focus on the outside, and whatever is hidden inside, you don't look at it. Okay, fine. Whatever way it is looking is fine. No, because ultimately the user is going to see it at service station, at somewhere or the other, while buying the spare parts. Right? Your spare parts will be bought, so it will look shabby. People will say it's not good quality. Right. You see early EVs. I started working with EVs in 2012. EVs started coming into India in import form in 2009, 8-9. That time EVs, if you see, you can easily, say, oh, this has been fabricated in a small shop. There's nothing in it, right? So you don't get that quality. So aesthetics is not just skin deep. Skin deep. It is deeper than that. You have to go right refinement. In automotive, refinement is everything. You buy a vehicle, it's vibrating, you get whining noise, you get, rattle on when you go through a bad patch of the road, you get clanking noise. Product is dead. You don't want it. So if you have your automotive engineers, you must have seen open vehicles sometime. You will see all the panels will have a rubber boot below that. Even though it's screwed hard to the chassis, but still there's a rubber. Why? It's for that refinement. Because I'll talk about that also later also, but we do stack up. The vehicle is a stack, right? One component sits over the other sits over something else, so it's a stack. So if you don't do damping at every point in time, the overall stack, a plastic sitting on a metal with a hard bolting will not make any noise that you can even hear. But when you look at the stack, right from front of the vehicle to the back of the vehicle, so many plastics, so many panels coming and joining together, those minor rattles will end up becoming a major rattle when you look at the full vehicle. And that is why it is important that you damp everywhere. And it also makes the part durable. Because when you damp, you are cutting the vibrations. You are softening the vibrations. So parts life increases. That force. Aerodynamic force. Very basic stuff. Whenever you are doing a 2-wheeler, 3-wheeler, 4-wheeler, this force, and especially this is very critical when you do high speed, because any engineer will tell you that 50 it starts to matter. You know, a 5 kilowatt requirement for a vehicle, 5 kilowatt motor required for a vehicle at 50. Same weight, if you increase the speed to 100, that 5 becomes 50. It doesn't become 10. It doesn't become, if you just do the, if you just do your power requirement calculation, simple calculation of speed and distance, right, you will get 8 for 100 kilometers. But when you do the full calculation, which includes this, then that will jump to 15. Because aerodynamic drag increases disproportionately, as in multiplication happens at higher speed. So you do 100, it's 15. You do 110, just 10 kilometers, it's 20. So it's a geometric progression that happens. And therefore, whenever you are doing a higher speed wave, this is one of the very important aspects. But these are the basics.